Question 19. Simplify 2 minus 3i over 2 plus 3i. Note I equals the square root of negative 1. Seeing this should tell you this question is from complex numbers. And we're asked to simplify. This is division under complex numbers. You have 2 minus 3i over 2 plus 3i. When it comes to division under this topic, you have to multiply both the denominator and the numerator by the conjugate of the denominator. The conjugate is 2 minus 3i. You multiply it by both the numerator and the denominator. So you have 2 minus 3i. Let's start with the numerator. You have this as 2 minus 3i in one bracket. In second bracket, 2 minus 3i over the denominator is 2 plus 3i in one bracket. In the second bracket, 2 minus 3i. Note that when you multiply a complex number by its conjugate, the result is always a real number. That in itself can be a question in the exam. Note that. Let's start with the numerator. If you're very good with expansion, and noting that what is in this first bracket is same as what is in this second bracket, which is same as having a minus b square, and this results in a square minus 2ab plus b square. Same applies to this. If you can do this expansion, you will save a lot of time. But if not, you'd have to multiply this 2 by this 2 by this minus 3i, the negative 3i by this 2, and this negative 3i by this negative 3i to get your result for the numerator. The shortcut method, which is this, if you are to do this, you have 2 minus 3i close bracket square, where 2 is a and b is 3i. So you have 2 square minus 2 times the value of your a is 2 and the value of your b is 3i. So you have times 3i plus, b is 3i. So you have 3i all square. You have 2 square as 4 minus 2 times 2, 4 times 3, 12. This is 12i. 12i plus, you have 3 square I square. 3 square is 3 times 3, that's 9. Then you have I square, because the square affects both the 3 and the I. From the previous questions, the square of I is negative 1. So you can have this as 4 minus 12i plus 9 in open bracket times minus 1. You have 4 minus 12i, then you have plus 9 times minus 1. This 9 owns this positive, this 1 owns this negative. We go for the signs first. Positive times negative will give you negative. Then 9 times 1 will give you 9. We collect like terms. You have 4 minus 9 minus 12i. This 9 owns this negative. Also, this 12i owns this negative. You have plus 4 minus 9. Plus 4 means what you have, minus 9 means what you owe. What you owe is actually more than what you have. So your result will be negative because you still owe. So if you take the 4 you have from the 9 you owe, you still be owing 5. So this has negative 5 minus 12i. So if you are to use this method, which is a faster method, you get minus 5 minus 12i. Let's do it the normal way. You can choose to repeat any of them twice. Then you continue solving. Repeat this twice. We have 2 minus 3i in the first bracket, 2 minus 3i in the second bracket. You close your bracket. This first gets this 2, and the second gets this minus 3i. So you have minus 3i over. For the denominator, we can repeat this twice, although this is a difference of 2 squares. If you can apply the expansion by difference of 2 squares, you would get this done in the shortest time. Let's apply. The difference between the first and the second is just the positive and the negative. One has a positive, the other has a negative. In that case, it's saying a plus b in one bracket, a minus b, is same thing as a square minus b square. And here you have the first one having a positive, the second one having a negative. It might be the negative before the positive, but one must have a positive and the other must have a negative. Noting that your a is 2 and your b is 3i, you'll be having 2 square minus 3i all square. 2 square is 4 minus 3i square will be 9i square. The square affects both the 3 and the I. So the 3 gets its square, which is 9. The I gets its square, which is I to the power of 2. And I square is negative 1. So you have 4 minus 9, negative 1 in brackets multiplying it. You have 4 minus 9 times minus 1. Note, you have to be very careful here. It's a technical part of the question. This 9 ohms is negative, so it's minus 9 times minus 1. Negative times negative will give you positive. 9 times 1 will give you 9. So you have 4 plus 9, that will be 13. So if you were to use this method in expanding this, you get 13 as your denominator. Note that this is the answer to the numerator using the shortcut, and this is the answer to the denominator also using the shortcut. So if you were to use the shortcut method to complete this question, you'll be having minus 5 minus 12i, the numerator, over 13, which is the denominator. It's best you don't leave your final answer like this. So you can have it as this equals minus 5 over 13 and minus 12i over 13. Just like in the previous question, since they are linked by a negative, and also if it's a positive, you give each value its separate denominator. So this is your final answer. Hope you understand. As backup to the fact that some students might struggle with using this shortcut method, though they can learn it, we go back to the normal method of expansion. We have to repeat this 2 minus 3i twice. So we have 2 minus 3i, one in first bracket, 2 minus 3i, a second one. The first one gets this plus 2. The second one gets this plus 3i. So we have plus 3i. We go to the numerator and we multiply. You have these two affecting both this 2 and this minus 3i. You have 2 times 2, you have 4. Then 2 times minus 3i will give you minus 6i. 2 times 3 is 6. Then you add the I to it. Then you have minus 3i times 2. Minus 3i times 2 will give you minus 6i. Then minus 3i times minus 3i, technical. Negative times negative will give you positive. 3 times 3 will give you 9. Then you have I times I will give you I square. Then over, we go to the denominator. We have 2 times 2, that's 4. Then 2 times minus 3i will give you minus 6i. Then plus 3i times 2 will give you plus 6i. Lastly, plus 3i times minus 3i. You have to be careful here. Positive times negative will give you negative. 3 times 3 will give you 9. Then I times I will give you I square. Next, we further simplify. We go to the numerator. We have 4. Then minus 6i minus 6i is just like algebra. You're owing 6, you're owing 6, you're owing 12 in total. So you have minus 12i plus 9. I square is minus 1. So you have minus 1 here, you close your bracket, over 4. You have minus 6i plus 6i. You are owing 6, you have 6. If you pay back, you have nothing. So both will cancel out. You have minus 9. And I square is negative 1. So you put negative 1 in bracket. We have 4 minus 12i. Then we have plus 9 times minus 1. Positive times negative will give you negative. 9 times 1 will give you 9. Over the denominator, which is 4. You have to be careful here. Negative times negative will give you positive. 9 times 1 will give you 9. We can write this as 4 minus 9 minus 12i over 4 plus 9 will give you 13. On the next line, we have 4 minus 9. You have 4, you are owing 9. What you owe is more than what you have. If you pay the 4 you have from the 9 you owe, you still be owing 5. So here you have minus 5 minus 12i over 13. This is not our final answer. We've gotten to this point. Now, you have a real number for your denominator. You can see what they mean by when you multiply a complex number by its conjugate, you get a real number. We have 13 here. We're not having 13i. That if it were 13i, it would be a complex number, not a real number. Here, we're having a real number. We can't leave our final answer like this, since they are linked by a negative. And even if they are linked by a positive, this method would apply. We'll be having this as minus 5 over 13 minus 12i over 13. This is our final answer. Minus 5i over 13 minus 12i over 13. Sometimes, in a question where you have options, this might actually be the answer. So any of these two would still work. Hope you understand. In summary, to simplify this, you just have to multiply both the numerator and the denominator by the conjugate of the denominator. Then you simplify, either using the normal method or the shortcut method. In both cases, you arrive at the same answer.